In this presentation, we'll look at circuits that have an inductor and a resistor, an R and an L, and thus are called RL circuits. If we have a battery and a switch connected just to the resistor, then we see that when you flip the switch, then the voltage is sort of immediately applied all to the resistor, or the current jumps up very quickly to V divided by R, the current given by Ohm's law. Now we're going to add an inductor, an L, to the circuit, so we will have an LR circuit. And we know that inductors do not like changes in current. It doesn't mean that a change in current can't happen. It just sort of opposes big changes. And so it leads to a more gradual change. So you see that when we flip the switch, the oscilloscope, the current is going to eventually get to the current given by Ohm's law, the V over R, but it takes a longer time to get there in a shape familiar to us from RC circuits when we were charging capacitors. So what is the effect of an inductor? We know that an inductor opposes changes in current. So it's not going to stop the change in the current, it's just going to sort of smooth out its effect so it changes less abruptly. So in an LR circuit obeys mathematics that are much like those in an RC circuit. So this behavior before, when it was the RC circuit, we were looking at the voltage over the capacitor. Now in the LR circuit, we're going to be looking at the voltage over the resistor. And it's as a function of time, it's going to eventually go to some saturation voltage, the full battery voltage, and that's going to be multiplied by 1 minus an exponential of minus t over some time constant tau. And a similar effect happens if we flip the switch to take the battery out, then the current is going to come to a stop, but not immediately. It's going to slowly change. And so we have sort of an exponential decay in this case. So in the case of the LR circuit, the time constant is now given by L, the inductance, divided by R, the resistance. And since we have the same mathematical form that we had in the RC circuit, we know that after one time constant, we get to 63% of the way we're going when we are increasing. Or if we are decreasing, then after one time constant, we're down to 37% of where we started.